In the mid-20th century, the world stopped what it was doing, grabbed a pair of binoculars, and gave its collective attention to the sky. The sheer mechanical brute force required to reach orbit was staggering. The Saturn V rocket was a colossal skyscraper built to explode, pointed directly at the moon. And it worked. We reached the finish line and planted a flag in the lunar dust. This chart tracks human spaceflight distance over time. Right here is the massive Apollo spike. But look at what happens next. The line crashes. For 50 years, we stopped going into deep space. Instead, we built the space shuttle. It was a remarkable feat of engineering that gave us reusable access to the edge of our atmosphere. With it, we constructed the International Space Station, a permanent orbiting laboratory. But both of these marvels kept us anchored just a few hundred miles above Earth.
While we mastered near-Earth orbit, the colossal vehicles designed to leave our planetary neighborhood were retired, becoming static museum pieces. Now, there is a new rocket on the pad. Visually, the Artemis SLS shares an eerie resemblance to the Apollo hardware of the past. 4 astronauts are preparing to suit up and take this specific vehicle on a journey back around the moon. To an outside observer, this looks like a remarkably expensive replay. We already checked this box in 1969. Why spend billions of dollars to do it again? Risking human lives to reach a destination we reached half a century ago only makes sense if the rules of the mission have changed. Apollo was a political sprint to prove we could get there first and come home. Artemis is a logistical marathon to build a permanent presence. Look at this mission architecture. We are no longer drawing a direct line from Earth to the moon. We are constructing a transit system, complete with orbital gateways and sustained surface outposts. Before you can safely build out that kind of massive infrastructure, you have to run a proof-of-concept flight. That is Artemis II. Astronauts like Victor Glover will be testing the Orion capsule to see if it can successfully sustain human life in deep space for weeks at a time. Artemis II is a destination mission in name only. It's actually a grueling stress test of the technology we need for humanity to survive off-world. The crew themselves understand the long-term strategy behind this flight, particularly Commander Reed Wiseman. This diagram scales the distance between our local planets. The trip to the moon is short, but humans cannot survive a months-long journey to Mars without mastering operations close to home. That turns the moon into an active testing facility, a place to refine our deep space technology while we are just days away from a rescue. As Victor Glover points out, the moon is the focus right now, but the end game is for humanity to reach the rest of the solar system. To get out there, we have to cross this exact threshold. Artemis II is the critical bottleneck, the teeny-tiny curb that we must step over before we can attempt the rest of the universe. Right now, that vehicle sits on the pad in the dark, thousands of tons of dormant power waiting for ignition. It requires a crew with total cohesion and extreme psychological readiness to strap into NASA's boldest test flight in a generation. Breaking Earth's gravity demands kinetic violence, a massive, continuous explosion to propel humans out of low Earth orbit. When those boosters light, they will break a 50-year ceiling, pulling these blueprints off the page and making them history. When you look up at the moon tonight, try to see it differently. That silver disk is an active, unfolding frontier for a new generation. The question of whether we will return to deep space has been answered. The only remaining question is whether we are going to lead or if we are going to follow. Artemis II proves our greatest chapters are yet to be written, marking the moment we establish a sustained presence in deep space.